So what is data verification? If you look at what has been described here about verification, is that it is the process of checking that the data entered into the computer or into the computer system matches the original source. So sometimes verification is a process of checking for, it's a manual process of checking for errors in data. For example, uh, if you look at the first example that is given here, which is a visual check, I'll sort of take this example to describe what do I basically mean by manually verifying that the data which is there on the source document has been accurately transferred or transmitted to the computer. So say for instance, you are typing out something by looking at a source document. What do I mean by a source document? Maybe something which is written on a paper. Okay, I have some data on a paper and I'm copying that data from the paper to the computer. So what I'll do is I'll look at the paper and then I'll type it in the computer. What I need to make sure is that whatever is on the paper, on the source document, has been accurately typed into the computer. This is visual checking. So you must have noticed that, or you might have been in a situation where you are typing something into the computer by looking at something which is written on a piece of paper or printed on a piece of paper, and you're just typing it out in the computer, copying it to the computer. So you make sure that whatever is there on the paper has been accurately typed into the computer. You just cross check visually to make sure that it is exactly the same. So this is one of the simplest methods of data verification, making sure that whatever is there on the source document has been typed exactly accurately into the computer as well. All right, but not is it always the case that uh, you are always sort of copying data from the source document and into the computer and then cross checking if the data is the same. But sometimes you may be asked to enter data into the computer twice, and the computer would verify if both the data that have been entered are the same or not. What did I just say? That sometimes it will be checked by the computer. The computer would ask you to enter the data twice, okay, and then compare the two. Compare the two in the sense that it will check if both the data items are exactly the same. Only and only if they are the same, they would be considered correct. And of course, the computer would not report any error and you can move on. But if after having typed something twice, if there's any difference between the two, the first one that you enter and then the second data that you entered, which is again, entering the same data again, if they are not the same, then that would mean that there is some error in the data and you may be asked to retype it because the computer is comparing the two. The best example for this would be the example of resetting a password. Whenever you reset a password, what are you required to do? You are required to enter the password twice. You enter it once, and then there's another option that says confirm your password. There, you could be given two boxes. So you enter the password once, and then it will ask you to confirm the password. So you will input or enter that password again. Now the computer will check if both the passwords entered are exactly the same or not. If they are the same, if they are the same, of course, this means that the password is correct. If there is any difference, then of course the computer would let you know or would inform you that, well, after having done the verification, after having verified the data, it has been found out that both the data items do not match. So you need to make sure that both data items match. So this is what I basically mean when I say the computer comparing or verifying the data entry. All right, and this may also be termed as double entry. Like visual check is one of the methods. This is a double entry method where a data item is entered twice to see if it is the same or not. Okay, so if you look at this, It says that a method of verification can be for the user to check visually that the data entered matches the original source. This can be done by reading the data displayed on the screen and comparing it with the original data on the source document. Okay, this is normally what we do when we are copying something from a source document. Okay, visual checking does not ensure that the data entered is correct. If the original data was wrong, then verification process may still pass. What do you think this means? Visual checking does not ensure that the data entered is correct. Yeah. Okay, personal error आ सकता है, but in what way? Basically, what do you exactly mean by personal error? Hmm. Mhm. Okay, so that could be one where while visual checking, you may overlook a mistake yourself. After even having made a mistake, you may overlook the mistake. But you know what he's actually trying to say here? He's actually trying to say is this, that what if whatever is there on the source document has been accurately typed into the computer? As far as the visual check is concerned, it is okay. But what if the data that you're copying was incorrect in first place? Are you getting what I'm saying? Somebody who actually wrote that data on the source document wrote it correctly, then that would not be your fault. So if I am the person who is copying it from the source document exactly to the computer, visually the data on the source document and whatever I have typed in the computer might be exactly the same. But what if the original data on the source document was incorrect in first place? Then of course visual checking would not be able to do anything about that. So one point that I wanted to highlight in our discussion on validation as well, uh, and it is applicable here as well, was that it's not that once you have implemented the validation rules into the computer, your job is done. I mean, it's not that if validation rules are there, verification processes are there, that means that, well, now the computer will take care of everything and whatever the data is, and you may not be on your guard at all. You, as a person who is inputting the data, still need to be careful. Why do you need to be careful? Because sometimes the data that we may enter into the computer might be fit according to the rules or according to the validation rule, but the data itself is incorrect. What if the data is incorrect, but it still lies within the range or within the rules of acceptability of the validation rule? Are you getting this or not? Okay, let me give you an example. If there is any confusion, of course, you can ask. We were talking about a range check where we were checking marks from 0 to 100. Remember that? A range check checks marks being entered from 0 to 100, say for instance. Now, 0 is allowed according to the rule, 100 is also allowed according to the rule, and any value in between 0 and 100 would be allowed. Yeah? Okay, what if the person who is inputting the marks, you know, is inputting the marks quickly because you are rushed for work and you have to finish it quickly. You have to finish, you do not have a lot of time. So, say for instance, you have to type in the mark of a student which was 57, but you accidentally type it 75. It is just a key press that you do differently. Now, the thing is, the actual mark was 57, but you typed it out as 75. This will be accepted as well as this will be accepted. Because although there is an error, but this is still within the rules or the limits of acceptability of the validation rule, which is 0 to 100. This is what I mean, that, well, although the validation rule is there, that does not mean that you are not on your guard at all. You still need to be careful as a user when you're inputting the data, that you are inputting the right data. Make sure that the data is correct, because if the wrong data that you're inputting is still within the limits of acceptability of the rule, then it would be accepted, although it is wrong. It is the same case with the visual check that I was just talking about. That what if the data on the source document has been recorded incorrectly in first place? You copy it from the source document to the computer. It is absolutely identical, but you did not know that the original data on the source document was incorrect in first place. Okay, so this is something that you must keep in your mind. All right. The next type of verification rule or verification check is double entry, double data entry method. Yes. Okay, so both are different. The example that I gave you of the range of marks was about a validation rule, where there's a range involved and there's a mathematical expression behind the scenes. That is not about checking, uh, that is not about verifying the data in a way, okay? Because I am not trying to match one data item with the other. With passwords, it is a case of matching to make sure that the accurate data has been input. So in that way, they are both different. Okay, so this double entry method is what I was just talking about a while ago, where it says another method of verification is to input the data into the computer system twice. The two items of data are compared by the computer system, and if they match, then they are verified. If there are any differences, then one of the inputs must have been incorrect. So the password option would be a very good example in this case, to see how double entry method works. All right. Next, we are going to look at what are hash totals. Hash total is also a method of verification. So what is a hash total all about? Hash totals can be used when inputting a set of data. A hash total is calculated by adding together values from an input field for all the records that need to be input. Before input starts, the user will manually add up the values. Once input is completed, the computer will compare the hash total it calculates automatically with the hash total calculated manually before the data entry was done. Now, what is this about? A hash total is a way of calculating any data by sort of doing a mathematical calculation, which could be, adding up a certain data item and arriving at a total. All right. Now, that total would be only arrived at, or a certain total would only be arrived at if you have certain values, because आपने उन्हीं values को add up करके उसका एक total किया हुआ है. Now, the thing is, once that data is re-input or it is transmitted somewhere, to make sure that there is no error, the same hash total is performed by the computer to see if the total that is calculated by the computer, or the hash total that is calculated by the computer, is the same that was initially manually calculated. The totals should match. If the totals match, this would mean that the data has been accurately typed in, okay, or it has been accurately transmitted without any errors. It would be further more clear when we look at this example. It might be a little confusing for you right now. So let's have a look at an example. Okay, say for instance, a user is inputting these coursework marks for students. There are three students. Every student has a candidate number and of course the coursework mark. So for one of the students, the coursework mark is 74. For another student, the coursework mark is 38. And for the third one, it is 82. Now what will the user do? The user will take up all these marks and will add up these marks. So when you add up these marks, the total comes down to 194. Yeah, this was the manual calculation that was done on marks before this data was transmitted, say for instance, wherever it has had to be, or before inputting it to the computer. This was manually done. Remember, it is not being done on the computer right now. It is being manually done. Do you believe that this total can only be arrived at if the marks were the same for every student as the ones that have been mentioned here? If I change any mark here, the total would not be this. Yeah. So these are the marks. This is the total that has been manually calculated. Now, once it is to be input into the computer, or for that matter, after having input, it needs to be transmitted or transferred, the computer would perform the hash total to see if the sum or the total of all these marks comes out to be 194, which was this. So, say for instance, 74 is changed to 83 and then 82. Here, the marks have been swapped around. The actual mark for this candidate was 38, but while entering it into the computer, the operator made a mistake and he input the marks as 83 instead of 38. All right. So what will happen is, this will impact the total. Will this impact the total or not? Total क्या आएगा? Sorry, 239. All right. So which is not what it should be. This is where the hash total is actually confirming that the data that has been input has not been input accurately and there is some mistake, because the hash total that would have been calculated by the computer should have been exactly the same as the one that was initially manually calculated. All right, are you getting this or not? So he tells you here that, well, the sum would come around to be 239 if you change one of the marks. And of course, 239 is not the same as 194. So there would have been either some sort of a data entry error, or an error even in the manual calculation. Can we say that there was an error in the manual calculation in first place? It could, either of these could be the case. All right, let's have a look at another example. Okay, again, three candidates, marks, coursework marks 74, 38, 82. The sum is 194 when you manually calculate it. But when the marks are re-entered, when the marks are entered into the computer, the first mark is entered as 73. The second mark, instead of being entered as 38, it is entered as 39. 1 mark more than what the student actually got. And then here, the mark is again 82. What will happen here, anyone? Look at the marks: 74, 38, 82, 73, 39, 82. Won't the total of the two be the same? Although there is an error? Yeah. So the thing is that sometimes hash totals may not be able to find out or any error in the data if the total comes out to be the same, because the data changed in a way that it resulted in the total to be calculated, the same total to be calculated as the one that was initially calculated manually. All right. So what does this mean? That the hash total may not work accurately in every situation, provided when there's an outside chance of the totals to be the same, even though the data would have changed, but it would have changed in a way that it would result in the same total as the one that was manually calculated. All right. Okay. Good. Okay, I would like to open up my notes as well. Let me show you something. So of course there's this description about double entry, and then there's visual check. Parity check we'll do at the end. Okay, this is also one of the methods of verifying the data. Okay, so hash total is what we just did. All right. Okay, one thing that we need to notice about hash totals is that hash totals can work on any data. Hash totals can work on any data. But when it comes to control totals may only work on numeric data. If we have a look at a different example of what hash totals are, uh, say for instance, according to this example, it says sometimes school examination staff are asked to do a statistical analysis of exam results. Here we have a small extract from the data that might have been collected. So if you look at this, you could see that there are two columns. There is student ID, and of course there is number of exam passes. Now these student IDs can be, this data can be used to add up and come up to a certain, hash total. For example, if you look at it, it says normally the student ID would be stored as alphanumeric type. You know what is alphanumeric data? What is it? Exactly. Any data which consists of both alphabets as well as numbers. But what he's saying is that for the sake of this particular, example, we may choose to convert the student ID into pure numbers so that we can use it for doing a hash total. All right. He's just trying to actually give you an example. So what he says is that uh, the hash check involves adding all the student IDs together, which could be this added to this, and this gives you a hash total of this. Now, once this student data along with the number of exam passes is entered into the computer, based on the manual calculation that was done on student IDs, you arrived at a certain total, which was this. When it is re-entered, if the student IDs have been entered correctly, the total should come out to be this. Yeah. So it is not only that you would probably be using hash totals on only numeric data, but you may also use other types of data uh, to calculate hash totals to check the accuracy of data. Now, in this case, we just want to make sure that the student IDs is exactly the same, or the student IDs have not been entered incorrectly. We are not talking about the exam passes for the time being. But what we are talking about here is that while entering the student IDs, you did not make a mistake. Because if in any of the student IDs you made a mistake, the total would not be this. So this is an example which is a little different from the one that we just discussed, from here in the book, where we were looking at the coursework marks, which would automatically, be be pure numeric data. But other types of data may also be used to calculate hash totals. All right. Okay. Now let's talk about what a control total is. Okay. So control totals are more or less the same as hash totals. They are calculated in exactly the same way, okay, but are only carried out on numeric fields. Unlike hash totals, which may use numbers, okay, to calculate hash totals or to check for the accuracy of data or to find out any errors, or something which is not pure numbers such as a student ID. I just gave you the example. We can even use that to validate the authenticity of data or the correctness of data, that the data doesn't have any errors. But when it comes to control totals may only work on numeric data. And how would that be? Let's see. So if we look at the example above that we just looked at in case of hash totals, it says that, say for instance, the head teacher wants to find out the average pass rate for the students. Okay, average pass rate for the students based on this data. Number of exam passes. This student has 6 exam passes, this one has 8, this one has 7, and this one has 3 exam passes. The teacher wants to find out what was the average number of exam passes by all the students, say for instance. So if you look at this example now, it says the control total can be used to calculate this average by dividing the number of students, okay, by dividing the number of students. How would you do this? Well, the calculation would involve adding up the individual exam passes of all the students. One of the students had 6, another one had 8, and then another one had 7, and then there was another one who had 3 exam passes. So you add them all together, and then what total would you get? The total would be 24. You will divide it by 4, which is the total number of students. So the average that you would get is 6. Now, when this data is entered, when this data is entered into the computer and the number of exam passes for each individual student is entered into the computer, added, and the average found out, it should come out to be the same, because this was manually calculated before the data was input, that what is the average exam pass mark for all the students. Okay, so if later on your control total calculates the average to be the same, that would mean that the number of exam passes for every single student have been entered correctly. Yes, it is still prone to error, you're right. There is an outside chance, just like in the case of hash totals, that what if the number of exam passes are altered in such a way that the total comes out to be the same, which is 24. Yes, so in that case, there's an outside chance that even though an error would have been made, but still, the control total would suggest that the data has been accurately transmitted, because it would still come down to, the average would still come down to be 6. All right. So yes, with all these error checking methods of verification, there is an outside chance of an error still getting through. They would pick up largely most errors, because you see, it is not, it would only be a coincidence for that to happen. That even if the data gets changed, it gets changed in such a way that the sums or the totals or the averages come out to be the same. there's a very slight chance of that happening. But of course, the chance of that happening is there. We cannot say that, well, it cannot happen. It can happen no matter how less the chance might be. So there is an outside chance of an error still getting through, but largely most of the data would be checked uh, through these methods, and of course it would be helpful. Okay, what are we left with? I think we are left with one more type of, actually two more types of validation verification checks. Yeah, checksum. We are left with two: checksum and the parity check. Parity check I will not do today. I will be doing checksum. That would be the last one for today. Okay, whatever is given in the book is a bit confusing. Not, I would not say it is a bit confusing, but it doesn't really explain it very well. So I would like to discuss this from my notes. Okay, now what are checksums? Checksums are again a little different from hash totals and control totals. How are these different? Let's see. What does a checksum do? Okay, a checksum is a value used to verify the integrity of a file or data transfer. Used to verify the integrity of a file once it has been transferred from one computer to the other. Now, what is meant by verifying the integrity of a file? Of course, ensuring that the file was transmitted correctly. Say, for instance, that is what it means. In other words, it is a sum that checks the validity of data. Checksums are typically used to compare two sets of data to make sure that they're the same. In what way? We'll just look at that in a bit. Some common applications include verifying a disk image or checking the integrity of a downloaded file. If the checksums do not match those of the original files, the data may have been altered or corrupted. Now, say for instance, you have downloaded a file, or you have made a mirror image of a hard disk. Do you know what is meant by making a mirror image of a hard disk? Anyone? Actually, copying the entire contents of a hard drive somewhere else, or maybe onto another hard drive for the sake of keeping a backup. Say, for instance, I have lots of important data on my hard drive, and I would like to make sure that I have a copy or a backup of this because it is important. So what I can do is I can create a mirror image of my disk onto another one. Creating a mirror image would mean that I would be copying each and every single bit of data on my hard drive onto another one as a complete backup. So it's just like doing a mirror image of the data from one drive to the other. Now, when we do that, either during that, or it could be a case of when I'm downloading a file, from a remote computer onto my computer. Now, when I make a mirror image of data on one hard drive onto another one, do you think in terms of the size of the data, it should be exactly the same? Makes sense? In terms of bits and bytes, it should be, if it is a mirror image, the copied data should exactly be the same size as the original data. Now, what is the checksum doing? Checksum has already been calculated internally, or checksum has already been calculated regarding the size of the data. Once the data has been copied as a mirror image, the checksum is going to check if in terms of the size or the number of bytes, if it is exactly the same or not. If the mirror image has exactly the same size, that would mean that each and everything has been accurately transmitted. But if in terms of size in bytes, I'm just taking the example of bytes. Of course, we can use a higher unit such as megabytes or gigabytes or whatnot. But if in terms of bytes, the copied image is exactly the same in size, actually the checksum would suggest that the data has been accurately copied 100%. The same would apply to a file that you download. It would have a checksum value with it in terms of the size of the file. What is the size of the file in kilobytes or maybe in megabytes or whatnot? If the downloaded file is exactly the same as the size of the original file, this would mean that the file has been downloaded totally correctly without any errors. Because the sizes of both the file, the original one before downloading and the one that has been downloaded onto your computer is exactly the same. This is what the checksum would basically do. And it actually tells you that here. Let's have a look at this brief description. It says, a checksum can be calculated in many different ways using different algorithms. For example, a simple checksum could simply be the number of bytes in a file. That's the simplest way of using a checksum for checking for errors in data. Just as we saw with the problem with transposition of the bits, deceiving a parity check, actually we haven't done the parity check, so this point would not hold. So when we do parity checks, you'll know what this means. Okay, so basically let's keep it to this point, that and keep it simple. You do not need to describe anything more than this, and of course we do not have to be too technical about it in terms of what the algorithm is or how how this checksum is achieved. But it's just that the checksum is ensuring that in terms of the size and bytes, two data items are exactly the same, whether a file being downloaded or it is maybe creating a mirror image of a disk from one disk to another. All right, is it clear or not? Any question, anyone? The last check is the check digit. That I will not do today because that is a little different and would require a bit of explanation. So we do not really have time for that for the time being. So I'll do that maybe in the next class. Up till this point, is there any verification check that is not clear? If not, you can ask your questions. Otherwise, I'll consider it done. Okay, seems that there is no more questions. So I guess that is it.